Hey, we have another problem from the UNT Integration Bee. This was sample problem number 8. We have the integral of secant to the fifth x dx. Now to start with, what I'm going to actually do is, instead of looking at secant to the fifth x, I'm going to do something really similar, but let's work with secant cubed x dx. This is a little detour, but we can actually use this in a minute. So I'm going to do integration by parts, and we're going to do the DI method or tabular integration. We're going to make two columns, one to differentiate, one to integrate. And actually, before I do that, I'm going to split this up. I'm going to write secant cubed x, we'll write as secant x times secant squared x dx. And I'm doing that because secant squared is going to be easy to integrate, and then secant x we can differentiate. And I'll take a derivative here. Derivative of secant is just secant x tan x, and the integral of secant squared x is just tan x. So we're going to have part of our solution right here on the diagonal. The first part is going to be just secant x tan x. And then we need to integrate this piece. So this is going to be minus, multiplying this together, we're going to have secant x times tan squared x dx. Well, for tan squared x, I'm going to use the identity and rewrite this as secant squared x minus 1. And what I can do is rewrite this, but I'll distribute in the secant. So we'll have our secant x tan x in front. Then distributing this in, we're going to have minus the integral of secant x times secant squared x is secant cubed x. And then we distribute secant x times minus 1, but we have another minus here. So this is going to be the integral of secant x. Well, this last piece here, secant x, that's a common integral. The integral of secant x is just going to be natural log absolute value secant x plus tan x. But now this piece is the interesting part. This is actually our original integral. This is actually the thing we're trying to find, right? We're just integrating secant cubed x, but we got another secant cubed x. So if this is I here, then this is also I, and we're subtracting an I. What I can do then is just add an I on both sides. Then this is going to cancel here, and then on the left we're going to get 2i. So now all I need to do is solve for I, so I'm going to divide by 2 here, and I just need to divide by 2 over here. And so this here is going to be our solution for the integral of secant cubed x. Okay, so now we have our value for the integral of secant cubed x here. I just took the division by 2 and wrote it as 1/2 in front of each term here. Now let's get back to secant to the fifth x. And the reason I did secant cubed x first is this is going to be very similar. We're going to do almost all the same steps. So to start, I'm going to rewrite secant to the fifth x as secant cubed x times secant squared x. And then we'll do our integration by parts again using the DI method. Again, the same way, I'm going to take my secant squared to integrate, and we'll differentiate secant cubed x. Again, the integral of secant squared x is going to be just tan x. The derivative here, we'll first use the power rule. So we'll have 3 secant squared x. Then chain rule derivative of secant x is going to be secant x tan x. We'll clean that up in a second. So we'll have part of our solution right here on the diagonal, just tan x secant cubed x. This part's going to be an integral here, so I'll bring my 3 out front. So multiplying things together here, multiplying secant squared times secant x, we have secant cubed x. Then here we have tan squared x, but I'm going to use that same identity we used before. Instead of writing tan squared x, I'm going to write this as secant squared x minus 1. And again, we'll just distribute here and here. So we're going to have secant cubed times secant squared x. This is going to give us secant to the fifth x. And then distributing secant cubed x times our 1. Then because we have a minus times minus, we're going to have a plus 3. Secant cubed times 1 is going to be just secant cubed x. Okay, now from here, just like the last time, we noticed we have secant to the fifth x here. Well, that's just our original integral, okay? So because we already used I don't want to create confusion, so I'm just going to call our original integral, in this case, n. So then this is also n. So we're saying n equals this. So this piece here is going to be minus 3n. And then for the integral of secant cubed x, well, we already found that. That was what we did at the beginning of the video. So I'm just going to write this for now as 3i. Then I can add 3n on both sides here. This is we're adding 3 copies of the integral. So that's going to give us 4n here. And so again, our goal is n. Our goal is the integral of secant to the fifth x. So what I'm going to do is let's just divide by 4 here. And we'll divide by 4 here. So now we've isolated our n. And now I think we're in good shape for our final solution. So we're going to have, let's write the first term as 1/4 tan x secant cubed x. Here we're going to have 3 times I divided by 4, so we're going to have 3/4 of this. So 3/4 times 1/2 is going to be 3/8. Then we're going to have just our natural log, absolute value, secant, tangent, plus c. And that's it. So actually, I think that's quite a bit of work for a simple, straightforward integral. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.